Unit 4, Day 5. Parabolas Day 1. This is of 2, so we'll have another day tomorrow to work on parabolas. We'll cover everything we need to know today, so tomorrow will just be more practice problems. So today will be heavy on notes, tomorrow will be very light on notes. We'll just work a few problems together. You know what? Today's notes aren't really that long, so let's back up and review, because I think this will help lead us into parabolas. So let's just look at the equations for the previous ones we've done. We started with circles, x minus h squared plus y minus k squared equals r squared. It's kind of a giveaway that that's a circle because the r for radius. Then we did ellipses. And the shape of an ellipse is kind of like the shape of a circle. So the equation of an ellipse is kind of like the shape or the equation for a circle. X minus h squared with a plus y minus k squared. But with ellipses, it's like there's a different radius in the x direction and in the y direction. So over a squared and over b squared. And obviously, if it's under x, you go that many in the x direction. If it's under y, you go that many in the y direction. The only other way to write this would be to put the b squared first and the a squared second. A is always the bigger one, but it rarely matters which one's which. Because if it's under x, go that many in x. If it's under y, go that many in y. Then we did hyperbolas. Hyperbolas don't look like ellipses, and so the big difference, I mean, in terms of what you write, it's a small difference. It's just a minus sign instead of a plus sign. But you guys have been around math long enough to know that that's a big difference, right? Subtracting and adding, completely different things. So x minus h squared over a squared minus y minus k squared over b squared equals 1. Which way is that one going? Is that left and right or up and down? Yes, left and right. So that one looks like that. And if we put the term that comes first determines, I'm not going to write the other one, but if we wrote the y term first, then it would be up and down. All right? Now, you've done parabolas before. You've graphed parabolas before. You're kind of familiar with parabolas. Do you remember, how can I ask this question? You know what makes a parabola equation very different than the other three equations? It makes it easy to spot on the test. So you got to be careful with circles, ellipses, hyperbolas, because they all got squared, 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 squared. When you have a parabola, though, only one of the terms is squared. It could be the y term, because we're gonna have sideways parabolas today. But for a parabola, there's only one squared term. And the one you're used to is what you just said a minute ago, Andrew. You said that the y is not squared, and that's usually correct for the ones that we graphed. Y equals x squared. Looks something like that. Parent function for a parabola, you know that. That's important to remember, because we're gonna mix some things up with parabolas. But if you know that if the x is squared, it's up and down. That's the normal one, you know. So don't think of it in terms of which one comes first. think of it in terms of what you know. You know what this graph looks like. So if the x term is squared, it's up and down. If it's the other way, if x equals y squared, well, then it's sideways. Yep. And obviously we're going to move these around and make them wider and narrower and flip them and do all sorts of stuff with them. But this is the important thing to know. If it's the one like you're familiar with, it's up and down. If it's a new one, it's sideways. So let's start with the one you know, the x squared term. So x minus h squared. These are going to be written differently than you're used to. Equals 4p. So this is new stuff. We've not dealt with p before. Times y minus k. Or y minus k squared equals 4p x minus h. Well, the first one, the x term is squared. That's what you're used to seeing. That's kind of the normal thing. So that one opens up or down. Up or down, not like a hyperbola where it's up and down. It's up or down. It's up if p is positive. This makes sense, I think. It's down if p is negative. P also does something else for the problem, but we'll hold off on that in a minute. For a moment, anyway. And if the y term is squared, that's the one we're not so familiar with. That's the different one. It opens left or right. Left if p is negative, right if p is positive. And again, that kind of makes sense. Negative is usually associated with stuff on the left. Positive is associated with stuff on the right. So that fits. The vertex is at hk for either of them, or both of them. So we're used to seeing that, the x minus h and the y minus k, that little part of it is the same as the other three. So that's kind of the starting point. So we don't call it a center for a parabola, we call it the vertex, although it is kind of the center of the parabola. And then one new term for sure, one new term when it comes to parabolas. The focus, that's a point, you know that. And kind of like all the other conic sections, the parabola will wrap around the focus. So you'll have a good idea that your focus is in the right spot if your parabola is wrapped around it. The focus and the directrix, so there's a new word, directrix, and the directrix is a line, not a point. Are p away from the vertex. So you'll start by going to the vertex, and then instead of having an A and a B to go up, down, left, right, you'll just have P. And you'll go that many, one way to get to the focus, another way to get to the directrix. And we'll look at how to know where to go in just a minute. The last new thing, and then we'll work one, hopefully make sense of this. The focal width of a parabola is 4p. which is the number that's in front of the not squared term. So whatever number right there is a measure of how wide the parabola is at the focus. Width at focus. So that's big because that sets, how narrow the parabola is versus how wide the parabola is. All right, enough background. Let's work one of these and put all this stuff into practice here. Y minus 3 squared equals 8 times x minus 2. Y minus 3 squared equals 8 times x minus 2. All right, so before we get into the details, let's think big picture and let's do a little sketch off to the side. Is this up and down or left and right? Left and right. How'd you know that? Because the y term is squared. So this is the different one than we're used to. So I know it's left and right. How about more specifically? Is it pointing to the right or is it pointing to the left? Pointing to the right. So it should look something like that. And we don't really know exactly where the focus is, but we know it wraps around the focus. So my focus should be inside the parabola. So even before I graph anything, I'm thinking, which way does it open? Where's my focus? And then I'll be able to graph and get all the details right. The vertex. Oh, I think we can figure out where the vertex is. Jonathan, where's the vertex?
At 2, 3.
Good. So we do that just like we did all the other centers. Now we're calling it the vertex. So at 2, 3, there's my vertex. I know which way it's opening. I don't want to graph it yet because I don't know exactly how wide to make it. All right, the number in front of the not squared term is 4p. So that means that 4p equals 8, and p then equals 2. So I need to go 2 away to get to the focus and 2 away to get to the directrix. Well, I've already thought about where the focus is, so I know I'm going 2 away, and if this parabola opens to the right, I need to go 2 away to the right to get to the focus. So my focus, I can just look at my picture, or if I guess I could look at my vertex and say that 2 to the right would be changing the x-coordinate by 2. So my focus is going to be at 4, 3. But I think the best way to do it is to draw a little sketch before you get started, because it's easy to know which way it's going, and then it's easy to know where the focus is supposed to be. So if you'll do this picture first, you're really likely to put the focus in the right spot. If you don't draw this picture, then you're kind of left guessing, well, wait a minute, where's my focus supposed to go? And you can go through the same thought process and figure it out, but doing the little picture first is a big help. All right, the directrix. So the directrix is P on the other side. So instead of going 2 to the right, I'm going to go 2 to the left. But the directrix is a line, it's not a point. So most people start with a point, but it's not the point there, it's the line there. That one's kind of tricky because it's also on the y-axis there. So that line would be an x equals line, and it would be x equals 0. Right. Focal width, we said, was just 8. Right? Whatever number's in front is the focal width. Now, be careful, that's the total width at the focus. So don't count 8 up and 8 down. Right? That would make a width of 16. So a little bit more math here. Let's go 4 up and 4 down. So at the focus, 4 up and 4 down. I guess I shouldn't even label that one 4. I should just label the whole thing 8, because that's what we're really doing, is a focal width of 8. And that helps us set the width of this parabola. So this looks like a pretty wide parabola here. And the only other thing that we sometimes ask is the axis of symmetry. But that's pretty easy, because once you've got a graph, it's pretty easy to see where the axis of symmetry is. Right there, that's a y equals line at 1, 2, 3. So kind of the two big things are, which way does it go? But you know that one already, right? Because if it's x squared, that's the normal one, that's up or down. If it's y squared, that's the not normal one, that's left or right. The second big thing to know is this 4p is that number in front. That tells you how far to go to get the focus and how far on the other side to get the directrix. Let's do one more. Let's convert to standard form. So we've been used to doing this with hyperbolas and ellipses and circles. Y squared minus 4y minus 16x minus 28 equals 0. Okay, so only one term is squared. That means it's a parabola. Y squared means it's left and right. That's not really what I care about right now. But it does mean that my goal is that it looks like y minus k squared equals 4p times x minus h. Right? I should have a y. My y is squared, my x is not. So to start to get it like that, let's put all the y stuff on one side. I guess leave it all on one side. And move the other stuff to the other side. So this is a little bit different than circles, ellipses, hyperbolas, where we kept all the x's and y's on one side, but that's because we had to complete the square for both. Here I'm only completing the square for y, so I'm going to leave the y stuff there, and everything else can go away. But from here it's similar. Half it, square it, add it. So half of negative 4 is negative 2. Square it, we get 4. So I'll need to add 4 to both sides. At the end of this unit, you're going to be experts at completing the square. Maybe you already are. Hopefully you already are. So y minus 2 squared equals 16x plus 32. Right, that's pretty close to what we're going for. Right, I got the y stuff right. What should I do to fix the left-hand side of the equation to make it match standard form? What's that? Take the 16 out, yeah. And now it looks like a parabola. A left and right parabola, and actually a right parabola. Where, let's keep going a little bit on this one. The vertex would be at -2, 2. What would P equal? We'll stop there. 4, because 4P is 16. Some people don't write anything about 4P. They just write P equals 4 because they figure it out. Other people start labeling things kind of like this. Well, 4P is 16, therefore P is 4. So whatever you need to do to help you see that this is 4P and then get what P is, then you're kind of off and running from there. All right, today's assignment, Unit 4, Worksheet 3, 1 through 8. So that's not all of them, because we'll save some of them for tomorrow. Now you already know how to do the rest of them, so you could do the rest of them if you wanted to. But we'll stop with that. We'll do number 1 together in a minute. But while I'm on the subject of worksheets, so due on Wednesday will be worksheets 1 through 3. So 1 and 2 should have done already, or pretty close to done. And we'll start on 3 right now. In fact, let's look at number 1. So grab your worksheet. This is Unit 4, Worksheet 3 in the packet. In fact, why don't you try to work that one as best you can, and then I'll work it up here. So give it a go. It's already in the right form. It's an x squared. That's your more familiar one. So see if you can piece together what that looks like, and then we'll come back and work it together. So looking at number 1, it's already in the right form. Vertex at -5, -3. Before I go any further than that, I think I should have done this at the beginning. If the x term is squared, it's up and down. It's positive, so it's up. So I know when I get through, my parabola better look like that. All right. Again, I think this is a good practice to get into. It helps you not get lost in the details of a problem and end up graphing a hyperbola or a backwards parabola or something crazy. I know my picture better look like that. Focus and directrix I can't get until I see what P is. But if 4P is 4, that means P is 1. So I need to go 1 away to get to my focus. And my little picture reminds me that 1 away would be up 1. So everything's kind of squinched in close on this parabola. So that would be at -5, -2 for my focus. My directrix is P away on the other side of the focus. So I'll go 1 away on the other side. It's not a point though, it's a line. So that's a y equals line at 1, 2, 3, -4. The axis of symmetry is the easy part here, as long as you remember that y equals and x equals. But if it's an up and down line, that's x equals something. So x equals -5. And then it doesn't ask for the focal width, but that's what I'll be checking. That's the last part of the graph that I'll be checking when it comes to grading, is to making sure your focal width is correct, because that controls the width of the parabola. So I don't know, maybe I should have added that, but the focal width is 4, so I need to go 2 on either side of the focus. And then just as best I can, sketch in a parabola, something like that. All right, so your job is 1 through, whatever I said, 1 through 8 for today. And then tomorrow we'll answer a few of those, and we'll go over a few more things like puzzle problems for parabolas. So tomorrow won't be much. And then again, this worksheet and the previous 2 worksheets are due on Wednesday, and we'll have a quiz on these on Wednesday, an open note quiz, so you'll be able to use these. So if you've got them completed, have them ready to go, you'll take the quiz with the notes or with the worksheets or your notes, whichever. And then you'll turn in the quiz and turn in the homework.